Good afternoon. This video discusses how I use the flipped classroom model in my physics courses. The first thing that I do is I make video lessons using Screencast-O-Matic. I like using Screencast-O-Matic because it limits me and confines me to a maximum of 15 minutes, which I think is important from an educational standpoint. Next, I save videos as YouTube videos and organize units as playlists. I then assign a video lesson using Edmodo, providing links to the playlist and any attachments that I might require, including handouts. Students watch the video and take notes using a composition notebook I provided them, or the note-taking sheets provided, as in this case. Next, we're going to take a view at a short excerpt from one of my flipped lessons.
Welcome to the Photoelectric Effect Part 1. Before we get started with this lesson, I want you to have both this video open in your browser, and I also want you to have the Photoelectric Effect simulation downloaded and ready to go back and forth during the discussion. In order to do that, go to the Photoelectric simulation link on my class web page. And when you click on that, this website right here will pop up, and what you need to do is download this simulation, which will end up looking like this. After you got it downloaded, you should see something that looks like this. Okay? I'll instruct you when we get that far how to change the various parameters that are all on here. But before we proceed, I want you to have this video open in one tab of your browser, and also to have this simulation up and ready to go for discussion. So please pause this video, and at this time, take care of that. All right, now that you're ready to go, let's talk about the photoelectric effect. Let's start off with what is the photoelectric effect. The photoelectric effect, just as its name applies, photo means light. Electric implies electrons. And of course, effect. The photoelectric effect is the effect of light removing electrons from a metal. If we take a look at this apparatus, we are going to start off with, in this video, talking about the rate of emission of photoelectrons. In other words, this apparatus is used to measure what is called photocurrent. Here's how this apparatus works. We have two parallel plates connected to a power supply. The left side is connected to the negative terminal of the battery, and the right side is connected to the positive terminal of the battery. The left plate, therefore, is negative. The right plate, therefore, is positive. The negative plate called the cathode, the positive plate called the anode. The light in the photoelectric experiment is shown on the negative plate. The light, if the frequency is great enough, we'll talk about that later, kicks electrons off of the metal, and because electrons are negatively charged, they are repelled by the negative plate and attracted to the positive plate. So they go over here to the positive plate, move through the circuit, pass through this microammeter because we're measuring a very small amount of current, not talking about a lot of current here. And electrons continue on through the circuit and go to the positive terminal of the battery. The battery does work, puts the electrons back on the negative terminal, which puts the electrons back on the negative plate, and the process continues.
You can do a lot of things with your videos, especially if you have a smart board, and include adding simulations and other things to your videos to help the learning process. We'll take a quick look at one of those right now.
So flip over to your photoelectric effect simulation. Okay, so here we are at the photoelectric effect simulation, and a couple things that you need to set up ahead of time here. One, it should start out with your voltage on 0. Turn it up to some positive value, in the neighborhood of 2 volts would be fine. You're able to control the metal over here that's in the plates as any of these values right here. We'll just leave it on sodium. And I believe yours probably looks like this when you first start out. Check the second box, current versus intensity of the light, because that's what we wanted to note the effect of here. Notice that the light is a violet color, about 400 nanometers, and we can actually vary that into the UV range and all the way down the visible spectrum into the red and down into infrared if we wanted to. We're going to leave it at 400 nanometers. Because we are not going to vary color here, we're going to vary intensity so you can see this effect. So note, right now, no electrons are being ejected from the metal at all. We have no light, the intensity is 0, shining on the metal plate. But if we take now and vary the intensity, we start to get electrons ejected from the metal. As we continue, notice over here in the graph, the brighter the light that we shine on the metal, and you can also notice the value in the current, the ammeter down here, is increasing. And it's increasing in a directly proportional way. Maybe your graph looks like something like this. Just click on this positive, expand the graph out until the line looks something like this so you can see it easier.
The next day, students start class by answering follow-up questions in their composition notebook. While they are writing down and answering questions, I'll walk around and spot check effort. Minimum standard is writing down what's written in the lesson. Often students will add questions or other notes mentioned along the way. We discuss the answers to these questions, and they are given the opportunity to ask questions about anything not covered during the follow-up questions. Once lessons are completed, students are then assigned some of the problems that cover a concept. And a video is provided to help them get help and check their answers. The next day in class, students are provided opportunity to ask any questions regarding the assigned problems with video from the night before. Students then break into small groups that do not exceed 3 and finish the rest of the problems that cover that concept, and the solutions to each are discussed as needed. When done, the students take a short quiz that covers any of the concepts addressed in both the out-of-class problems and the in-class problems. We are fortunate in our high school to have a one-to-one iPad program, and so in my class, students take their quiz electronically using an app called Shobi. Prior to this, they would have done a paper and pencil quiz. Steps 6 through 8 are then repeated until the unit is completed and we've gone over all the problems that address all the concepts covered in the units. We then, of course, do the traditional review process and take a unit exam like we always have. That concludes my process for how the flipped classroom works in my physics courses. If you have any questions or would like access to any of the resources, please email me at the email address given at the front of this presentation.